Hello everyone, and thank you very much for coming today, and thank you very much Gnosis for inviting us. We're very happy to be here. Today I'm going to introduce TxHash Network. It's a problem that we've been working for almost a year, and we are just recently actually starting to make it public. And I'm going to tell you first the problem. So most blockchains and DLT or distributed ledger protocols or technologies work in such a way that you have many nodes, which are computers that synchronize blockchain information with each other. These blockchains have a few characteristics and also a few problems. They communicate with each other, they share information, try to keep the ledger in such a way that every single node has the same information. But there's two main things that we believe that are very important and that are going to be massive issues in the near future. The first of all is that there are no incentives currently to run a node. If you use the blockchain at the moment, you might be using probably MetaMask, or you might be using Jax or any software that connects to central nodes, and you don't have any incentive to actually download the whole blockchain. There's also another issue that is massive, which is this lack of interoperability between DLT and Web 2.0 services. There are not that many tools that allow you to easily connect, if you're a developer, your application, or if you are, let's say, a store owner, your solution to the blockchain and receive notifications in a very simple manner. So for the first problem, it's getting increasingly more expensive to run a node. Just 1 week ago, Ethereum reached 1 terabyte of information, of blockchain information. And due to the nature of blockchains, this is just increasing because blockchain is a permanent ledger that stores the information indefinitely, and every single node has the same information. So it's getting more expensive to operate one. Nodes are essential for decentralization, and not only for decentralization, also for if you want to audit transactions in the past, we have to have the whole history in order to be able to see what happened. Take for example, I read an article about Ripple. There's in the article it said that Ripple, for example, lost the first 500,000 blocks of the history, and there's no way to recover that. So no one has that information, according to the article I read. This is a very big problem that could eventually happen in other blockchains. And there are no clear incentives, actually. I mean, why would I run a full node if someone else is providing the service? But the problem is that these nodes actually have massive potential because they are the access point that developers have to build applications on top. Now, regarding applications and interoperability, we already have the Web 2.0, and blockchains are separated completely from this. They operate on their own space, on their own siloed space. And there's no easy way to actually connect blockchains to Web 2.0 applications. If I'm a developer and I want to build an application, I have to, most of the time, run a full node or rely on a third party, such that we have, for example, Infura that is providing the service, but there are central authorities. There's a slow adoption, mostly because the development is also very slow. If I'm a developer and I want to develop, I have to learn first about the blockchain technology. I have to, as I said before, synchronize my node and have all these steps that require a lot of time. And we need to move the focus on blockchain in crypto space from protocols to applications. This is a natural step. In 1994, when the email and the internet was first introduced, and many people didn't know, introduced in a mainstream way, I mean, people were focused mostly on building protocols. And there's even an interview that talks about the email back in '94, where people didn't know what was email. We are in a very similar phase where there's not that many applications. There's mostly focus on protocols, and everyone is talking right now about scalability issues, like trying to make as many transactions per second as possible. But no one is really talking about the applications, how we're going to build applications on top. And for that, we do not only require to write a lot of information to the blockchain, we also have to be able to read a lot of information from the blockchain, which is very critical. And this is where TxHash comes. TxHash is the first It's the first decentralized network that solves the interoperability issue that I mentioned before by providing incentives to full node operators. And we basically incentivize them to share the current infrastructure that they have in order to track transaction information that happen in the blockchain regarding payments or smart contract events. And we are basically using the core of our blockchain as a service platform in TxHash.com to build the TxHash network in a decentralized manner. So this is pretty much how our current infrastructure looks like. Basically, we have full nodes running that are completely synchronized with blockchains of Bitcoin, Litecoin, and Ethereum. We have a tracking algorithm that takes care of getting notified whenever there's a new block, and also when new transactions happen in the blockchain. And on the other hand, we have users that are adding ledger requirements or conditions to our platform. For example, whenever I receive a payment on my Bitcoin address, do the following action, and then we connect that with all the events that are triggered. For example, if a Bitcoin payment is received, then notify Slack, for example, or a custom API. Then we let developers to easily integrate their applications with ledgers. And of course, we have released our beta in app.txhash.com. You can visit it. We also have a service partnership with the FTTT that allows us to integrate very easily with hundreds of different services. And well, TxHash.com. We developed this for the first time. We started the first lines of code in 2017, last year. We released the alpha in October of 2017. We released our beta on February of 2018, this year, with the launch of the partnership with the FTTT. We already have 1,000 registered users. We're tracking already 3,000 addresses, and we have notified 100,000 events that are emails, webhook notifications, and FTTT events. The current technical infrastructure, basically we have a microservice architecture consisting of web servers, databases, and some apps, daemons that run. We have the core event tracker service that takes care of synchronizing the blockchain information with the application's events. And we have some full nodes. We have Bitcoin D, Get, Parity, etc. We're experimenting also with new protocols such as EOS, Tesos, and others. And of course, we have a third-party bridge provider which connects all this information with other services such as CFTTT. We have a staging environment for the testnet using Command in Ethereum, the testnet in Bitcoin, etc. And we have live environment, mainnet basically, which is the beta application that I was telling you before. And the core tracking event service works as follows. So we have the web part, the tracker part, and the blockchain part. This is basically the internet facing. Users create new trackers. So for example, track this address, and when something happens on this address, do this action. Then our tracker communicates with the blockchain and receives new blocks. So when miners basically get a new block and they add it to the blockchain, we get notified about that. We basically check the transactions that are included on the block against the tracker database that we have. And we trigger an action if conditions are met. This is in a very simple way how the core tracker event service works. This is how we plan to do it with the TxHash network. We want to basically decentralize this, and there's a lot of challenges to achieve here, because we have also a lot of possible attack vectors. We have a lot of economy model issues that we have to solve. And in a very rough way, how this works is that the users will create their trackers in the same manner that they are doing in our software as a service at the moment, and they will need to stake a certain amount of TXN tokens, plus pay a fee depending on the tier of transactions that they want to use for our service. We have then the blockchain nodes. They are going to install the TxHash node plugin, and they are going to also stake a certain amount of tokens. And whenever they provide valid events, they are going to get a reward. If they behave in a bad manner, they misbehave, they are going to get their stake penalized. Whenever the conditions are met, the network is going to take care of trigger events in a secure manner, and it's going to execute actions like API, webhook request, or sending an email, or adding, for example, a transaction to a Google spreadsheet. How to become a TxHash Network node operator? Well, it works in the following manner. Node operators install our plugin, then they deposit TXN tokens to the smart contract, then they prove ownership by signing a message, for example, with the address that they deposit tokens from, and then the plugin starts tracking network addresses. Then we have a set of auditors that validate the result to avoid civil attacks, and we reward or penalize the node behavior. This is a very simple way how it works. We have then we have made our tracking engine in such a way that it's agnostic. This means that we can integrate as many protocols as we want. We started working from the beginning with at least 3 of them in order to understand how to abstract it properly, so we can integrate later other protocols such as EOS or NEO or Stellar, for example, or many others. These are just examples. In a very simple manner. And this is the plan in the future, that we can integrate as many protocols as possible. And the future challenges that we have, and the reason also of why we are making the token cell at the moment is because we need resources to do research, a lot of research for mitigating civil attacks when staking the TxN token, seeing how we're going to mitigate the denial of service attacks, basically if someone tries to spam our network, how we're going to do the decentralized notifications to these services in a very safe manner, compatibility issues that we're going to face when, for example, Plasma or other scaling solutions appear, of course how we're going to use the decentralized databases, such as, for example, BlueCell. And of course, we have to research a lot about how the node economic models are going to behave whenever the price of our token goes up or down, whenever there's more node operators that the network needs or less operators. We need to try a lot of different scenarios in order to get to the best formula. And of course, see what level of decentralization we need, because for some parts of the architecture, we might want to have a lot of level of decentralization, but for some others, it might make sense to keep some level of centralization. We will need to see what the market actually wants. And there's a massive opportunity, because as the tracking data that we gather grows, we will have opportunity to do analytics, and analytics for forensics, for decentralized exchanges, for analysis on transaction fees, just to mention a few of them. The white paper was released less than 2 weeks ago. Then you can read all the information regarding our project, and of course, all the technical details. And the roadmap that we're following at the moment, as I mentioned before, we started the development last year. We launched our first prototype with Ethereum payment notifications in the 3rd quarter of last year. By the end of the year, we had already Bitcoin and Litecoin notifications added to the system, and we started the development of our EFTTT API bridge. This year, we have been focusing on launching the beta, making this EFTTT service partnership concrete, and of course, adding smart contract notifications from Ethereum. And what we're doing at the moment is doing the token cell. Afterwards, what we want to do, after the token cell is finished, is research on the proposed architecture, as I mentioned before, and all the challenges that we have, add secure support, implement additional protocols, research scaling solutions such as charting or off-chain support. We want to also launch our testnet on the 1st quarter of 2019, then the mainnet with the rewards on 2019, and afterwards we're going to focus on the analytics part that I mentioned at the end of the challenges. This is our team. I'm Diego. Hernane is our front-end developer, and Norbert is our back-end developer. We have an amazing set of advisors that are really have been very helpful to us. We have Nadia here, who we're very happy to have her actually, and we're very happy that she invited us. And this has been the presentation. If please you have any questions about the technology, if you want to use our platform, or if you need help with anything, please contact us here at network@txhash.com and TxHash.network, and also for our software as a service, TxHash.com. Thank you very much.